But before we step there, I just want to understand, how will you ever test string theory? And we know in advance that you have naysayers out there, physicists among them, who are saying you're diverting time, resources, graduate students, faculty positions to something that doesn't even classify as a legitimate scientific theory or hypothesis, because you need to be able to test it. So let me hear your response to that.
I think that's a really fair question. For any theoretical framework where you're trying to describe things, if there's a big intellectual leap, right, and for example, extra dimensions is a pretty big leap, you have to justify that with a payoff, right? You have to say, what is the benefit that I'm going to give you in terms of, structure and predictions and what you're learning from this theory. So to push back on the, how are we going to test it? Let me observe first that in particle theory in general, the timescales between predicting structure in particle theory and then being able to see it in experiment over the last half century have gone, increased in size considerably. So one example of this is the prediction of the Higgs boson made by Peter Higgs, which took about 50 years from the prediction that this particle should exist to its observation at the LHC.
That means the theorists are just way ahead of the experimentalist.
I would say that dialogue of theory and experiment is really important, but I'm just pointing out that direct verification by experiment of lots of things is hard. That doesn't mean that one shouldn't do it. For string theory, I would say the problem is a lot worse than it was for something like the prediction of the Higgs boson, because the energy scales are so massive to directly observe strings. So for me personally, I'm interested in trying to decide whether string theory is useful a lot faster than that in the point of view of my career. And I remain very agnostic as to whether that's the case. Now, in contrast to that, in string theory, if you found a solution in string theory that produced particle physics like we see in our universe, none of those numbers are free. They're all determined by the configuration of these extra dimensions and the structure of the theory. So it's a huge array of physics that you have to get right all at once. And here I've been talking about particle physics, but you also have to answer questions about cosmology and the large-scale structure and history of the universe. So how are you going to decide if string theory is wrong